Louisiana, more often than not, it is hot and humid, and we have these coastal structures, such as bridges, pipelines, or buildings, that are damaged by corrosion. Over time, these metals will experience lots of humidity and oxidation, and will gradually get weaker. This is an increasingly pressing issue in Louisiana, and a very important one at that. Now, what is corrosion? Corrosion, in short, is a chemical process through which metals are converted into other compounds, such as metal oxides, sulfides, or hydroxides. Examples of this include the oxygen/copper layer found in copper after oxidation, and the rust in iron, in which there is an iron and oxygen mixture. Basically, oxygen binds to the metal and changes it. Corrosion can be sped up through various means, such as constant moisture, an increase in temperature, the presence of acids, and salt. This process makes metals weaker and more unreliable over time. For example, iron, when it rusts, loses the desirable qualities of why it was picked in the first place, losing tensile strength, becoming brittle, and basically overall weaker. Corrosion can be predicted based on a metal's placement on the reactivity series, which is a table that states how reactive a metal is with other solutions, in which elements such as iron, zinc, and other metals react with acids fairly easily. Metals, however, lower in the reactivity series, such as gold and platinum, hardly react at all and thus don't corrode. There are also many different types of corrosion, the most common one being uniform corrosion, in which there is generally a visual dulling of the surface, and then it becomes rough and discolored. This is the most common type of corrosion and the type that we experienced in our experiment that I talk about later on. Another type is pitting corrosion, in which passive metals such as stainless steel eventually corrode in random sections or pits. This method is most likely to occur in the presence of chloride or oxidizing salts. There is also stress corrosion cracking, or SCC. And in this type, the metal will crack due to the corrosive environment, usually due to tensile stress on the metal at high temperatures. There are many more types, but the last one I'll be talking about is galvanic corrosion, in which two different metals are in a conductive liquid and they experience a chemical reaction due to having different electrochemical properties. These are all very similar, but there's slight differences that we have classified them each as. Now, there are a few things that people can do to make existing materials corrosion resistant. One example is that oftentimes people will use zinc-plated steel, and in this type of steel, a thin layer of zinc is put over it because of its ability to resist corrosion. In fact, zinc corrodes at roughly 1/30th the rate of raw steel. This essentially acts as a shield and protects the metal underneath. Zinc-plated steel is also very similar to galvanized steel, and one of the only differences between these two methods is how they are made. In zinc-plated, the steel is usually dipped into an electrolyte solution with zinc particles that start to cling to the surface of the steel once the electricity is applied. Whereas in galvanized steel, it is dipped into molten zinc which then cools around it. While technically different, these both achieve the same effect. Another possible prevention is simply changing the material. A common material used is stainless steel. Even though it is typically more expensive, it is a favorite because of its many qualities, from being easy to clean, being durable, and being long-lasting. Stainless steel is also made with chromium, a metal which has a unique property in steel of making a sort of self-repairing layer of chromium oxide. If the surface of the steel is scratched or damaged, the chromium in the steel reacts with oxygen in real time to reform the protective layer, and this layer also acts similarly to the zinc to protect the metal from corrosion. On the other hand, carbon steel is the least corrosion resistant. This is one of the cheapest steels, and it is the type of steel used on the Golden Gate Bridge. It's also the reason why it's constantly being repainted, which is to cover the rust. As well, red metals such as brass, copper, and bronze are among the most corrosion-resistant metals. However, they are rather expensive compared to some of the previously mentioned steels. In fact, over time they won't actually corrode, but rather turn green due to oxidation. We actually decided to try and do an experiment of our own. We decided to get 3 different types of metals and leave them in solution of vinegar and salt for about a week. As you can see here, we have a zinc-plated bracket, a stainless steel nail, and a nickel/washer thing. And as you can see, this is the zinc-plated bracket put in water, and as you can see there's clearly a difference. It's quite tarnished.
And moving on to the one with the galvanizing agent on it, you can see that it's not quite as tarnished. I missed the front while spraying it, but you can clearly see there's a difference between the two, and the galvanizing spray clearly had an effect. The others didn't really corrode in the week that we dunked them, so we just kind of ignored them.